Hey folks, how's it going? It's Mr. Murray coming to you with a breakdown for the Course 1 Honors quiz on statistics, and this is for cohort, my apologies there, went to circle that, cohort A2. So in this video, what I'm going to be doing is I'm going to be walking through this quiz here. I'm going to be breaking down kind of some of the key ideas, things you might want to know, things that I saw that I think went well, things that I think we should improve, because my hope behind this video is that you will take a look at your quiz, okay? You'll take a look at my solutions, kind of go through as needed, feel free to skip through the video as you want, all right? And really get a sense of where you're doing well and where you need to improve. Because I have had questions in terms of, am I gonna allow a retake? And so what I would say to that is, instead, what I'd like you to do is let's focus on your learning, okay? Figure out where you did well and where you need to improve, and build up those skills so that next time you have the opportunity to do better and earn that boost that I think you're capable of earning. All right, so the first question is going to be about relative frequency. And in this question, we have a survey about your favorite video game system and your preferred social media app. And so I asked, what percent of respondents like PS4 and TikTok, and what type of relative frequency is this? So in this case, what we have is PS4 and TikTok. So there are 5 people that like PS4 and TikTok, and there are 191 total people. And I really cannot stress enough how important it is to have the fractions here. Those of you with percents that didn't include fractions, if you got the answer incorrect, you did lose a lot of points. And that's because the fraction is the most important part. Remember what I said in class? I think anyone can type 2 numbers in and figure out what divided by what, right? That's not a skill that I want to assess. Anyone can do that. What I want to know is assess your ability to figure out what numbers you're typing in. That's what I want to see. So that's why the fraction's so important. So those of you not having fractions in there, you're going to get that feedback from me. Now this 5 out of 191, that's going to turn out to be about 0.02617. So in other words, it's about 2.6%. This is a joint relative frequency. Now, a lot of people mixed it up with a conditional, but remember, if you are dividing by everyone, it cannot be a conditional relative frequency, because conditional means that there's a condition and only people that meet that condition or things that meet that condition get counted. Let's take a look at the second one for an example. So in the second one, what percentage of respondents prefer TikTok given that they prefer Switch? So given that they prefer Switch means now the only people that we want to look at are the people who prefer Switch. And that is not everyone anymore, right? That is only 44 people. So now you can see I'm dividing 39 by 44. Now, technically, this is equal to 0.886. So this is technically considered to be 88.6%, or I would even take 89% as an answer on this one. This is a conditional relative frequency because the key word here is the given that. And also, if you're not dividing by everyone, you're dividing only by some people. Okay, that's really, really important. So identifying the types, really, really important. It's something some of us struggle with on the project as well. So if you're someone who struggled with the identification of them on the project and here, what that's indicating to me is we might need to do some additional work to make some of those ideas stick. All right, so we're going to now finally write a relative frequency question whose answer involves the fraction 49 over 83. It's actually right there. Now, you could have used this table. You didn't have to. My idea with giving you the numbers was that I thought you would use the table. If you didn't use the table and you wrote a question that still makes sense, I tried to give you the credit because in my defense, I was not necessarily 100%, clear that you had to use the table. Okay, so what I'm going to do is I'm going to now write a relative frequency question whose answer involves the fraction 49 over 83. So I would say, what percent, this is an example, what percent of people prefer TikTok given that they prefer none of the systems. Something equivalent to that. What percent of people who don't like any of the systems prefer TikTok? There's a lot of variety, and I was very generous about this one in terms of as long as it was something that was correct, but the question has to clearly indicate through the use of the words that I am not, because the thing is, when I read it, I'm going to do the fractions in my head. Okay, and maybe if I don't get the same thing as you, if I don't get the 49/83, that's where I might mark you down. So be super careful about that one. All right, so feel free to rewind if you'd like to see me do any of this again. Otherwise, I am moving on to the next question. And this is about one variable data distributions and SOCs. So in this one, statement 1 is true. The data are skewed to the right, and that's because you have that one value off to the right. If you did take a look at the mean and the median, you could kind of cheat a little bit there, so to speak. You could notice that the mean was higher than the median. And remember, when the mean and the median are not about the same, that's an indication that there is a little bit of skew. Okay? The fact that the mean is more than the median indicates that there is a number that is large, unusually large, that is pulling the mean up, so the mean is higher than the median. And when that's usually large numbers are off to the right of small numbers, as we see here, and that's an indicator that we are in fact skewed to the right. The mean is the appropriate center measure of center. Now, one thing that was confusing was a lot of people said 1 and 2, but actually 1 and 2 contradict each other, because if the data were skewed to the right, then you wouldn't be using the mean for the center, rather, you'd be using the median, okay, because it's skewed. And the idea is, if you think about it, what is the mean? The mean is 4.67. Versus the mean is 4. It's not really a fair comparison, but if you think about it, if you think about the number 4, versus 4.67, if we said that, okay, that's about 5. So if we think about which one is more in the center of the data, to me, if that 13 wasn't there, right, 4 seems like it would be the center of the data. And what's nice about the median is that it actually accounts for it. It says, you know what, if there's a number that's way off to there, the median will kind of help balance that out, because there's also going to be a number that's like this one, that's unusually small, or that's kind of smaller, that's on the left-hand side, okay? So the mean is not appropriate. The IQR is. Now, the big thing is you cannot choose 2 and 3. 2 and 3 are also contradicting each other, because if the mean is the appropriate measure of center, then the data is symmetric. So then you shouldn't be using the IQR. Remember, mean goes with standard deviation, as you see here. Median goes with IQR. Okay, so I've explained it verbally. I'm not going to write this one. Okay, shape, outlier, center, spread. Again, you should write complete sentences. I'm going to abbreviate on this one just for time's sake. So the shape we've now talked about, the shape is skewed to the right. The outliers, yes, there is an outlier. You can leave it at 13. A lot of people did 13,1. It's not really necessary. I think I might have said that maybe out loud. I'm sorry if I did. You can leave it at 13. The comma 1 doesn't really make so much sense, in that if there was more than 113, I would question whether that was an outlier, because it's usually like I consider it one thing that's off by itself. That's how I define it. So if you did that, it's okay, but please you can just stick to just the number. That's okay. Okay. Now here's the issue with the center and spread. The one issue I saw is a lack of information. So remember, in the center, you have to include a few things. Remember, first, you have to start with the y. So since the data is skewed to the right, this is why you're choosing the measurement. The median of 4 represents the center. I'm going to write represents center. Okay? So y, what's the value? Right? I also saw a good example. The median of 4 represents the center because the data is skewed right. That's fine. You said the measurement, you said the value, you gave the reason. Perfect. The order, as long as it's a coherent sentence, I don't care how you hit those three. Make a sentence that makes sense. Give me the three pieces of info. Make it a complete sentence. We're good, right? I'm open to being flexible, but I need you to present that information. It's so important. Imagine if you had just learned this and you didn't know what that meant. Okay, since the data is skewed right, we're also going to use the IQR of 2. So, okay, some people actually write the calculation. If so, that is great. Awesome. All right, so again, feel free to rewind if you have further questions. Otherwise, I am going to go ahead and move on right now. All right, in this next one, we've got the diagnostic test score versus the final grade score. So basically what we did is we took a look at how well they did on this diagnostic test and whether it was correlated with how they did overall. What you're going to notice is the points are far from the line. So the first thing that I wanted you to notice is that the correlation coefficient here of 0.47. Now, you need to take that and you need to put it into context. So the context is there is it's got to be weak, positive. I saw a lot of weak, strong. That doesn't make sense, folks. Think about it. You can't be strong and be weak at the same time. Those contradict each other. So you need to have a strength, weak, and a type, positive. There's a weak positive correlation between diagnostic score and final grade score. Okay? So what have you done? You've said the type, you've said the strength, and you've brought it back to the context. That's extremely important, and people may have been marked down if the context was missing. One thing we did struggle with that is important is whether I should use this as my standard for whether to place people. So the thing with this model, okay, is that the correlation coefficient tells you a couple things. It does tell you the type and the strength, but it also tells you whether a line is the best method for modeling the data. And what you can see here is that because the correlation is so small, it's so close to zero, it's a bad correlation, and a line, as you can see with all these points far away, doesn't do a good job of modeling the data. So the answer you tell your department head is no, because the correlation suggests that the linear regression or like a line is not the best way to represent the data. So this is not the model that we should probably use. To me, it doesn't look like any function reliably models the data. And I don't think that personally I would use this method based on what I'm seeing. It doesn't seem right, because if you think about it, people who did very poorly on the diagnostic did well, and people who did very well on the diagnostic didn't really do much better. But look, there's plenty of people who got F's and ran the whole gambit. So it doesn't necessarily tell you anything. If you think about it, it's not necessarily the most reliable way, right? There's people with poor scores, right? Look at this. If your high score is a 16, think about that. 8 out of 16, that's not a passing grade. Yet these individuals got an A in the class. Okay, so that's important to think about. Last one was a social justice concept. So it had to do with, I looked at different household incomes and how many, what percent of people owned a desktop and laptop computer. So basically the interpretation is going to be similar. There is a strong positive correlation, I think strong, fairly strong, between median household income and percent of households with desktop and laptop computers. I'm just going to say that out loud. Again, there is a strong positive correlation between median household income and percent of households with desktop or laptop computers. Now, in terms of the regression line, we now need to use, now you're supposed to use the formula, folks. Let's take a look. So we're supposed to go 0, 0, 0, 2. Now we plug in the 175, okay, plus 62.479. Now, if you have Google, you can do this. So we're going to do 0.002 times 175,000 plus 62.479. And what I get is I get about 97.48%, 97.5, 97. I can handle all of those. So about 97%. And this is an interpolation. And why it's an interpolation is because if you look at the data that was used to generate the model, the lowest possible data value, that was not as good as it could have been. Let's use a line. The lowest possible data value that was used to make the model was right here, about maybe 42,000, and the highest number was here. So any x value we use to make a prediction, if it's between these two lines, it's an interpolation, and if it's outside of them, it's an extrapolation. And we can clearly see 175, that's undeniably, if we're in the middle here, undeniably it is within the range. It's an interpolation. All right, folks, so hopefully this helped you answer some of the questions on this quiz. I'm really hoping that if you continue to have questions, of course, I completely understand. Please reach out to me to seek out some of that extra help. I'm available during office hours. I'm available over email. Please make the most of it. I really believe in you. Keep it up. Stay positive. And remember, you can do it. All right, until next time, folks, have a wonderful day.